that kind of stuff. And so they wanted to have a system where the students could get involved on both the tech side and the plant science side. So we built this little device and then had some requirements. We needed a device that we could interface with through Wi-Fi, so we could connect to it and control the parameters for the pH and the other plant parameters. We also want to be able to download data that was recorded on the system, so need to have local storage and need to have a bunch of different sensors connected to it. This was a great little project and worked really well. And the next year, he came back to me and we did another grant for another project. This time it was doing air quality monitoring. So this is sort of where my environmental science background comes into play. We were working with the students. They could build these air quality monitors. They could take them home. They could put them in places around the city, and they could use that to determine the air quality of various areas. And again, for this project, we need to have a system we could interface with over Wi-Fi to control it and collect the data. You need to have local storage to record all the data, and need to have a bunch of different sensors that could easily be connected to it. Along the same time, in my personal life, I was working on replacing the doorbell in my home, because if you are anything like me, you don't see something like a doorbell as something you just buy off the shelf. You figure, I could probably make that better and spend a lot more money and a lot more time to get something that's probably a little bit better. So this was another project I was working on. Same idea. I want to have a doorbell I could change the ringer on, adjust the volume, maybe have some lights in case I missed the sound cue, that kind of thing. So for this project, I need to have something that I could interface with over Wi-Fi to upload and control the audio, something that would be able to have local storage to store the audio and have a bunch of different devices connected to it. So I started realizing that all of these projects had the same foundational requirements. They all needed the same basic libraries used, the same web server, the same storage controller, the same everything. So instead of trying to duplicate that functionality over and over and over again, I decided to see if I could spend some time to make a generalized system that provide all that functionality from the ground. So this is where we come to what we're calling the FabricaIO framework or FabricaIO project. So this is a framework for easily creating and modifying projects. And that's the key point here. It's supposed to make it easy to swap things out, to iterate, to change things. It's currently built on known systems, so using ESP32 and Platform.io. So if you know anything about those devices, you'll be very familiar with that. We're not trying to reinvent the wheel here. We're just trying to take that wheel and put it on a slightly easier to use car, so to speak. And so ideas make it modular so that you can easily plug in different devices or different things as you need them. We have well-documented REST APIs for easy interaction. So if you do want to hook this up to a larger system or automate things with it, you can do that. And we also have a collection of libraries and standardized interfaces to make adding new sensors or making new sorts of things much easier. So I'll go through that in a minute, but first I want to talk about what it's not, because I want to make sure that there's not a misconception what we're trying to do here. This is not a replacement for other ecosystems or frameworks. So things like ESP Home exist, and they're great. If you're looking to hook up something to Home Assistant, ESP Home is one of the best tools out there. But we're not trying to replace that. We're not trying to replace integrated systems like the M5 series, M5 stacks. They're really nice modules that all click together and make great systems. This is more of a general purpose. I have a little project. I just want to have a foundation to build off of on instead of starting from scratch. It's not for very highly specific or time-sensitive applications. By that, I mean, if your application has strict timing requirements in the micro or second range, this is probably not going to work for you, because this runs a lot of event queues and things like that to make systems more modular, and therefore it doesn't have the highly precise timing of maybe other applications. It also doesn't have super low power mode or anything like that, at least not yet. So if you have a very specific, very, you have a task that you have to do a very specific kind of build for, this is probably not right. This is more of a general purpose system. And of course, it's not finished. We've been working on this for a few months, and about 6 to 8 months right now on this project. So we're still very early on the stages, which is great. That means that you can get in now on the ground floor and help us sort of shape what it becomes in the future. So who is our target audience? Well, people with little or no code experience. So if that's you and you're looking to get into these systems or learn a little bit more about them, this would be great for you. If you're an experienced developer, I'm going to explain why this might also be a good option for you to help speed up your development process. And I think there's a lot of good application for educators and community programs. Again, as an educator myself, I built a lot of this with an eye towards those systems. So I'm going to go through each of these use cases one by one. So if you're an
Hello? Uh-oh. Have we lost you? Clearly.
Last time that happened in this room, you had to shut it down and restart it. Shut down Zoom.
Shut down. Hello?
Are we back?
Yeah.
Okay. Not sure if what we lost, but I'll sort of just pick up where I left off, and I'll be sure to come back to this if anyone has any questions at the end. So as I was saying, you can download a little app here. You can add all the devices you want. You can configure them right in the app. Don't have to code or learn programming. So if this is something that is scary to you, you can do that. You can then select the board and any other parameters you need for your project. You can connect to the appropriate serial port, and then it'll compile and deploy your code right from the app. You don't need to worry about installing complicated tool chains. You don't need to worry about your environment being set in a particular way. Everything is sort of self-contained here. And that's it. You're done. You've deployed your hardware app, and you didn't have to worry about a lot of that complicated stuff if that is something that is a bit intimidating to you. And now that you've deployed it, the question is, how do you interact with it? Well, it has a nice web interface. So once you hook it up to your Wi-Fi network through a captive portal, like any sort of commercial IoT device you might buy, you have our nice little web interface here. This is the very basic web interface. So I'll talk about customizing this in a bit. But as you can see, it gives you access to all the different things on your device. You can see all the devices you have connected to your device hub, your project. You can toggle your pumps, configure your pumps for how much water they dispense, how often they dispense water. You can actuate your pumps, trigger them to go manually. You can see all the sensor data. That's all the sensors that are hooked up to your device will automatically be populated there for you. So you can just see that and see what it's like. And then you can also access all the files on your device that are being saved there. So for instance, if you're recording the data, you can go and download the data that all those sensors are recording to be processed in Excel or whatever. So you have a nice all-in-one interface where you can go into and get everything you need right there. And you don't have to worry again about any complicated setup. Well, that might be great for experienced users. And you might think yourself, well, I'm an experienced user. I do a lot of programming. This is nothing intimidating to me. Why do I need this sort of hand-holdy stuff? And so I think that there's still applications here for experienced users. One, as I mentioned, it's super easy to get up and running. It uses standard libraries, standard environments. The tool chain is as easy as installing a Visual Studio Code plugin, and you're good to go. It provides all of the boilerplate that you need for your program to save time. So you don't need to worry about setting up an API for your project. The API is already there. You don't need to worry about setting up a device controller for storage access. There's a storage controller built in. It already has times, NTP time syncing. It already has all these other sort of built-in libraries and event triggers that are there for you. So you don't have to worry about that. You can focus on the part of your project that makes your project good, your particular devices, your sensors, what you want your product to do, and not about getting all the other supporting stuff up and running. And again, since it uses standard tools and libraries, you can pull in any sort of external, anything that works on an Arduino, anything that works in an ESP32 can run on this just fine. And there's always large communities out there that already have support and documentation for their libraries and their systems. So again, we're not trying to replace that. We're trying to integrate that. And again, we have fully documented APIs, so it's easy to integrate with. And I'll talk about this in a bit, but we use a lot of polymorphism, which means that you can spend less time maintaining code and more time using what we already provided to build on top of it. And we have lots of utility classes, so that means that there's already a lot there that is ready for you to get started with. And lastly, there's a really nice customizable interface. I'm going to talk about that last part first. So as I mentioned, the interface uses our standard API. The onboard interface is just a standard web page with JavaScript, and you can customize it any way you want. This is an example where I made a little interface for an LED controller. So instead of having all those buttons, now we have a brightness slider, 2 on-off buttons, and some settings for setting the timer. And again, this was super easy to do because our base interface gives you examples of how to access all the APIs on the device. So all you have to do is pick and choose which ones you want to use, and you can build out your interface. And it's as simple as writing an HTML file and a JavaScript. But since the APIs are also accessible externally, you can also build external interfaces. If you want an external interface to go and harvest data, maybe you want to hook it up to your Grafana interface, or maybe you want to have your own custom management that can manage a dozen of these sort of devices. This was the one we built for our hydroponics system. You can see it collects the data externally, so our little devices don't have to worry about that. So the point is there's lots of different options for you to customize your interface in whatever method is most convenient for you. It's also very easy to add new devices. If we have a device that you don't have on your system, this right here is a sum total of all the code that's needed to be written to get a simple I2C sensor hooked up to the system. Most of this code is just making the system aware of what the sensor can do, like what measurements it has, temperature, humidity, etc. And once that's done, the device will automatically populate that web interface, make this whole thing accessible through the API, be able to log all that data internally. All you have to do is describe the sensor, and everything else is already there for you, ready to go to work with it. But let's say we already do have a device that works. We have a nice pump, and you want to maybe use one of these pumps for your own garden project. But our pump, all you can do is you can go to the web interface or through the API and trigger the pump. You're like, well, that's not going to work for me. I want a pump that I can trigger on a timer periodically. Well, you can inherit that upstream pump class, add to it whatever timer logic you need, and that way you can deploy a new one using the polymorphism. Therefore, your child class now will inherit all the benefits of the parent class and only need to maintain your new code. All the upstream code, you don't need to maintain that. That's already being maintained by us or by whoever made that library. You'll need to focus on the new stuff for your particular project. And likewise, let's say you want that pump to do something more. Maybe you don't want to be triggered on a timer. You want to be triggered off of another sensor reading, like a soil moisture sensor to water your plants at a particular time. Well, you can, again, take that base class and add a sensor trigger to it. So this is what we're trying to get with modularity, is that you can take these different modules, a sensor, actor, like a pump, and you can combine them in whatever ways you need to make them do whatever you want to do without having to rewrite everything from scratch or make a unique piece of code for everything. You can basically reuse all the code that we already have and not have to keep redoing the same code over and over. It's also, and this is very important to me, very easy to share projects. If you make a project and want to share it, fortunately, our projects can be fully described in a JSON file. And they can describe every device you have, all the parameters for those devices, so all the sensors, all the devices like the pumps. And our app can export and import that JSON. So if you are trying to share this project, all you have to do is share the JSON. You don't need to fork our base repository with all our code. You only need to maintain the JSON that describes your project, and our system will implement your project in the app and everything from our code. So you don't have to worry about maintaining the upstream code or forking our project and then getting behind as we make updates and you're not syncing it, and suddenly you're 3 or 4 commits behind or a dozen commits behind the upstream code. You only need to maintain your only need to maintain the project description and any custom assets like interfaces that you want to provide with that. And we are developing methods to automatically deploy interface alongside the firmware. So that's something we're hoping to achieve in the future. So I've talked about here with experienced users and inexperienced users. So I want to take a moment here to talk about educators and community groups, which I think could be a big application for this. So if you're an educator, what makes this really nice is it's very easy to share and deploy to an entire classroom, an entire group. So if you have a makerspace or a classroom and you're trying to get a system up and running, you can give your students that app and give all the students that JSON description. They can all load it up and it can all be deployed. You don't have to worry about them, even if they're doing their own computers, not one you control, setting up the tool change, set up any of that kind of stuff. The other thing that makes it nice is it allows students to design and take ownership of their projects. What I mean by that is, since it's very modular and customizable, you could, as an educator, have a collection of pumps, of sensors, of devices that you want to say to your students, these are what's available to you. You can design your own project and you can implement them any way you want and plug them all in. And it really allows students to not just follow a prescribed, oh, you're building this project with these devices. They can really say, oh, I want to measure these particular environmental factors, or I want to automate it in this particular way. And it allows them to customize it very easily without having, again, to relearn or re-implement all this stuff from scratch, or you having to maintain dozens of permutations of the code. But it also means that students can dive into the code if they want to. The backend is accessible, everything's open source. So if students want to learn more about code, the more advanced students, they want to add devices or dive into that, they can do that. They can do interface development. They can do device development and learn about how to program from there. And the thing that I'm really excited about is applicable both to science and technology classes. So if you have a community group or a makerspace classroom or whatever it is that does technology, and in that technology class, they can build these devices and learn about these devices. And then if you have a science class, they can take that device and use it. They can learn, they can gather data, they can process the data, they can write a paper even about what they collect and what their study is. They can design the science behind it. So it really allows you to have a constant through line from the technology that they're building and then seeing how the technology is used to do science or to do work. So I've talked a lot about sensors and stuff like that, but I want to be clear that this project is not just for scientific research or classrooms or work like that. It can also be used for more, I don't want to say, whimsical projects. So for instance, this is a word clock that I had purchased. It's a nice little word clock. It says the time in words, which I think is quite fun. However, the couple of problems I have with it is very bright and you can't control the brightness of its display, which means that at night, it becomes a nuisance. I have to find myself unplugging it because it's basically like a night light. So I wanted to modify this to improve it. I thought this would be an excellent opportunity to use this project. So I'm going to take you through my process of this project and how it worked for me and so how it can be applied to other applications. So first, I broke the project down to the separate devices I'd need to have hooked up. I wanted to have an LED display controller. Now, we didn't support an RGB LED display controller at the time. So that was one thing I had to make. Then I wanted to have a periodic task to check the time. That's something that was already built into it. So I didn't have to worry about making that. Now I want to use a parameter trigger to see if I could measure the brightness of the room using an ambient light sensor and adjust the display's brightness based on that. And that was also something I added, was a new sensor for ambient light. And so the only idea was to create a single class that would then incorporate all those separate devices into one and make an interface for all those items. So the nice thing about that is I now had a general purpose RGB LED controller and a general purpose, what I didn't mention here, but a general purpose ambient light sensor that could then be reused in future projects. So in the end, not only did I finish the project, but I also made all my future projects easier because now I have expanded the amount of devices that are easy to be plugged in. I can plug that LED controller into another project if I need to use a different kind of display. Or if I want ambient light sensing in another project, I have that sensor ready to go. So it's all, it basically increases the ease of your next project, every project you do. So what sort of are next steps for this? Well, first, we're looking to create a website that can be a central database of all the devices and projects that are on there, so you can easily search and find and share projects and see what devices are supported and to what extent. We want to finalize our interfaces and generate thorough documentation for all of them so that we can have a nice, easy-to-use system. We want to refine our app experience, get better UX, improve the search, things like that to make it a better experience, a more stable experience for everyone using it. We want to continue to expand the utility classes so it makes it easy to customize things in ways that you can hook up things to each other. We want to expand our list of support devices. So for instance, adding new controllers, add new sensors to make everything, to give you more options out of the box. And we want to add, ideally, Node-RED style linkages so that you can, in the app, instead of having to type in anything manually, you can just say, I want this sensor to trigger this pump or this device and have that all done sort of graphically as an even easier way to interface with it. And of course, we would like to improve our code base, but we do want to focus on accessible code. We've taken great care to make sure that our code base is readable, well commented, and with that eye towards education and community groups, making sure that as we improve the code base, if it comes down to if we can make the code more efficient or more accessible, we're going to lean towards the accessibility side of things to make their code easier for people to develop and learn and implement. So how can you get involved in this project? First, if you want to build a project, that's a great way to get involved. We're looking for people to test it out. Just try making something with it. Let us know the issues you have or the things that went well. You can find our documentation and contribute to our code on GitHub. There's our address. We are often meeting on the Cascade Steam Discord, one of the sponsors, I believe, of Linux Fest this year. So if you want to come by and chat, we'll be glad to talk you through setting up the project, learning all about it, and getting involved. And of course, if you want to contact me directly, you can email me, and I'll be happy to discuss anything I can with you. So I've left a lot of time for questions, so I'm happy to entertain any questions you have. I know that was quite a high-level overview, but I'm also happy to do any demonstrations if people are interested and see sort of how things operate. But I will leave it there, and thank you for your time.